Afternoon. I'm Alexa Schmitz, CEO and co-founder of REEgen. We're a New York startup using biology to produce clean, sustainable, domestic rare earth elements and other critical metals. With electrification technologies we have available today, we could eliminate 50% of industrial greenhouse gas emissions. But for this to happen, we will need far more rare earth elements. So rare earth elements are a group of periodic table elements that have special properties that make them necessary for most of today's electronics. They're in your mobile phone, high efficiency lighting, and even the computer screen you're staring at right now to watch this presentation. They're essential for renewable energy, especially the infrastructure like electric vehicles or wind turbines. They're also critical for a wide array of defense technologies, including radar systems, missile guidance, stealth technologies, such as those found in this F-35 Lightning II or a Virginia-class submarine. But here's the problem. So a single wind turbine requires over a ton of rare earths, but getting that results in huge amounts of toxic waste and greenhouse gases. So the same could also be said for two F-35 Lightning II fighter jets. Unfortunately, these immense impacts have led the Western world to basically outsource production of rare earths and some other critical metals. And now China alone produces over 90% of global rare earth materials. This is creating a huge supply chain risk and also a problem for national security. At REEgen, we believe that if we can solve the national security problem by solving toxic waste problems, and to do that, we are building a clean biological solution. Instead of generating hazardous waste, we can use a variety of waste from other industries to recover the rare earths with our feedstock agnostic process. We have proprietary genetically optimized bacteria that can extract and purify the elements with greatly reduced environmental impacts. This allows us to produce sustainable US-sourced rare earth elements at a competitive price. Our process involves two key steps. We have rare earth bioleaching and bioseparations. For bioleaching, genetically optimized microbes produce a proprietary leaching solution called a biolixiviant. This is used to leach metals from a solid rare earth feedstock. The solution of those leached metals is then separated into individual rare earths using genetically optimized microbes that can selectively bind the different metals. Our bioleaching system is ready to scale rapidly, so while we continue to de-risk the bioseparations, we're developing a rare earth concentrate as our first product, capable of generating over $1 million in revenue in 2026. So our primary revenue stream will be through the sale of our rare earth products or rare earth extraction systems, but we can also alleviate cost of landfilling by processing the industrial waste as a service. And then finally, we're also working with the mining industry to see if we can provide sustainable solutions for them through technology licensing. And to date, we have 10 letters of support from customers across all three business models, and we're in fact working on a term sheet for our first commercial pilot project. Our go-to-market strategy involves three phases. First, we're scaling our rare earth bioleaching system, and we're going to sell the rare earth concentrates to existing refiners outside of China. Our second phase will involve commercializing our separation technology to refine the rare earths ourselves, increasing the value of our product. And then finally, we're going to expand into other critical metals such as gallium or lithium, and this will really allow us to unlock exponential growth for the company. The global market for rare earths is expected to be worth $34 billion by 2032, growing very rapidly. Consumption outside of China is what we see as our serviceable market, and then we estimate our obtainable market for our expected possible output per year at $1 billion. To date, we have tested rare earth recovery from over 20 different feedstocks. All of them have different values in terms of contained metals, their input costs, and availability of the feedstocks. We've developed really high traction among recyclers of steel and catalytic converters who generate these smelting wastes called slag, which turns out to have really high levels of rare earth elements, especially magnet critical neodymium, the element in those motors for wind turbines and other engines. In fact, these smelter slags can contain up to $500 per ton of rare earths, and the US is producing over 1 billion tons per year. It's a huge opportunity where we're going to be looking first. We have identified our beachhead market among the slag producers in the catalytic converter recycling industry, where the slag from recycling of precious metals contains about 30 kilograms of rare earths per metric ton. This is higher than some active rare earth mines, and you don't even need to dig it up. We have traction with customers totaling production of about 50,000 tons per year, which is a value of more than 6 million once we can capture that market. Additionally, these smelters often must pay a high tipping fee and are eager to find cheaper ways to dispose of their slag. So if you think of just tackling this market, we can produce enough rare earths per year to enable manufacturing of 100 offshore wind turbines per year, alternatively 300 F-35 fighter jets. REEgen is leading the field in building a sustainable global rare earth extraction supply chain. We're differentiated in the fact that we can both extract and separate to purify the rare earth elements. We have no hazardous waste production, and we are feedstock agnostic. But we have a really great team in place to make this happen. This is our executive team, but to date we have 7 employees with strong technical and business expertise. Also, we're supported by super great advisors with experience both in rare earth mining industry and deep tech startups, as well as the technology for further de-risking. To date, we've raised $1.5 million through investments, grants, and accelerators. This includes startup funds through the Ignite program at Cornell. But we're actually currently raising $4 million in a seed round to launch our commercialization strategy. This will unlock a scaled bio-leaching system for that pilot project, a bioseparations pilot demonstration, our first feedstock partner for producing the AutoCAD slag, and a buy-off agreement for the recovered rare earth concentrates. So unfortunately, I won't be able to stay for the networking session, but if you're interested in more, please reach out to me by email. Thank you so much.
Great, thanks, Alexa. I'd like to open this up for questions. If anybody has any questions for Alexa, particularly seeing she won't be here for the networking. Yep, Lavina, let me see if we can bring you up to stage and you can ask your question.
Hi, there I am.
Yep, there you are.
Hi, Alexa. I'm, great work. Hugely important area.
Thank you.
I'm wondering to what extent you've kind of looked at the permitting and kind of the waste that you produce from that, like to what extent you have like disposal problems out of your process. When I've looked at companies like this in the space, that's been kind of harder than expected. So I wanted to hear if it's easier or harder for your company versus some of the competitors.
Yeah, it's a really good question. And looking into that has led us to actually work more closely with the partners and trying to fit into the strategies or mechanisms they already have for landfilling or putting the waste into another stream. So in some cases, they sell it off as road aggregate or even get paid to put it into road aggregate. So we want to make sure that whatever we do with these industrial residues, that we are leaving something that's less hazardous than it was, and that we can work with the sort of material flows that already existed, or even upgrade the flow. In some cases, we're seeing that we might be able to use these materials as supplementary cementitious materials where previously they were not able to be used as such.
Does anything hit the water supply? I think it's that liquid waste sometimes is the challenging one.
Yeah, so we do generate a lot of liquid waste, but we're actually working on technologies to try to keep our water as circular as possible. And then actually the biolixiviant, this leaching solution that we use is, first of all, it's biodegradable, but also it's reusable in itself. So once we remove the metals, we can use it again to leach. Yeah. And then eventually to take the water back into use, and any of the organic or other nutrients that are in that solution, we're exploring downstream uses for as well. So really trying to create as much of a zero waste process as possible.
Okay,
really great question. Thank you.
And Alexa, there was a question in the Q&A from Albert Charles, and so it asks, how does this compete or augment companies that use chelation for heavy metals from unproductive soils? So I guess, more, is this competitive with that, or are you kind of synergistic or something that can be used together with that?
I would say that it could be both. So it really depends on what metals they're looking at. Right now, we are focused on rare earth elements. However, when we expand into other metals, that would make us competitive with those companies for sure. One thing that we're trying to avoid is making our business model dependent on remediation, although I would love to be able to apply our solution in a really just how can we remediate and clean up the environment direction. Uh, yeah, it's mildly competitive, although our focus on the slags and actually our next focus beyond slags is expected to be sort of residues from the recycling industry for electronics. That is still pretty separated from what those companies are doing, and there's plenty of industrial residuals to pull metals out of. So space for all, I guess I would say.
Yeah, great, thanks. Any other questions out there? All right, and one question I have, Alexa, again, I've seen your presentation a few times, and I guess what scale are you at as far as like for being able to capture these or kind of process these rare earths? I know I've seen you go from, we'll say, milligram scales to multi-milligram, and sort of where are you at right now, and what's kind of the trajectory, assuming you get your funding for that? And I know that's always a question that that comes up, so I'm sure you're prepared for that one.
Yeah, sure. And it's great to talk to people over the years, but we're actually currently at the kilograms, so several
Great.
kilogram scale, and
Nice.
that is coming up from milligrams from the academic lab where we were working in flasks with milliliters, and now we initially went to 4 liters of this bioleaching solution in the bioreactors, and now we've actually been able to do it in 40-liter open tanks. So it's definitely scaling quite well without loss of efficiency thus far, and our goal actually is to push that to 1 ton per day processing capability for the slag by the end of 2025.
Oh, well, impressive.
Yeah, so that will set us up for our pilot project.
Yep, great.
Thanks.
Yep, now let me see. Don't know if we have any other questions. We'll give people just another minute to see if there's any other questions. Otherwise, looks like we are on track today. Usually we're behind schedule, so. All right, well, thanks, Alexa. And yeah, just to remind everybody, if you want to reach out to Alexa afterwards, she does have her email up on the screen.
Please.
So, yep, great.
Thank you so much.
Yep, thanks.